Right, good day, boys and girls and you colleagues. My name is Mr. Mpahama. I'm a subject advisor for mathematics. Today, of course, we are going to look at the calculus, but under calculus specifically, we're going to look at cubic functions, right? Talking about cubic functions, you'll remember that it's very important to know when you talk of the cubic functions, what is it that we are referring to? What type of the functions is that one? Remember now, you have a linear functions, you have quadratic function, exponential function, as well as what? As well as the cubic functions. Those one are very, very important. Right now, when you look at this one here, the graphs of cubic functions, what is it that is different with other graphs? I think that is very important things that you must look at today. Remember, boys and girls, you know how does quadratic functions look like. You know how does hyperbolic functions look like. It's very, very important. Right, today we're going to look at more details on the cubic functions, which of course is very, very important. Right, now the standard form here for cubic functions is ax. You can see here, hope you can see it clear. It's ax to the power of 3 plus bx squared plus cx plus d. Right, this is a standard form for the cubic functions. Of course, when you talk of the quadratic functions, you remember that here we have what? We have ax squared. The quadratic one, we have f at x is equals to ax squared plus bx plus c. Of course, if I have to write the linear one, now remember that is only what? Ax plus b, and then the exponential one is b to the power of x there. Right, boys and girls, it's very important to know when you talk of the quadratic function, when you talk of the linear, when you talk of the exponential and the hyperbolic functions, what is it that we are referring to? Please make sure that you follow, because I think the difference between these functions are only few. They are only few. Not everything that you'll find that in the quadratic functions, you also have it here in the cubic functions. Right, now let us start with the shape of the graph first. How does the shape of the graphs looks like? Of course, the shape will be determined by the value of a. You remember now here, we have what? We have f at x is equal to ax, so exponent of 3 plus bx plus cx plus d. Right, the value of a here is the one that will tell us how does the shape of the graphs looks like. Okay, right, let us look at this side here, where a is greater than 0. Then you can see that if a is greater than 0, then the shape looks exactly like this one here. It means the function will increase first, and then we have the maximum turning points, and thereafter the functions decreases and then increase. Immediately when it decrease and increase, then we'll have the minimum turning points. Now what we can say in short is that immediately if the value of a is greater than 0, of course we are going to start with the maximum turning points. Good. Now that's the first point that is very important. A greater than 0, we start with the maximum points. It means the graph increase first. Good. Now, what if a is less than 0? What if a is less than 0? Then you can see on this side, if a is less than 0, then let us look at the cubic function shape. Now it means the functions will decrease first, right? The function will decrease first. Of course, we are going to start with the what? With the minimum turning points, which is very, very important. And thereafter, then the function increase and decrease after, which will lead us to a maximum turning points. The 2 points are very important. A less than 0, the graph decrease, then increase. Then we're going to have the minimum turning points. If the a is greater than 0, then of course the function will increase first, and then we're going to start with what? We're going to start with the maximum turning points, which is very, very important. Right, I think that is the first thing that you must look at right now. The second one now is the procedure for sketching the graph of the cubic functions. You remember we have the procedure as well when you sketch the quadratic, when you sketch the hyperbolic, as well as the exponential one. Right, now remember those three quickly. What is it that you need when you sketch the quadratic functions? What is it that you need when you sketch what? The hyperbolic as well as the exponential, so that at least you can be able to compare the two. Then to say, okay, what is difference with the cubic functions as well as the quadratic as well as the hyperbolic functions? Of course, will agree with me that first of all, what we need to determine there is the x and the y intercept. It's very important, right? The first thing that you must look at is the x and y-intercept, right? X and the y-intercept, that is the first thing that you must look at. Boys and girls, you know, when you talk of the x and the y-intercept, I always call it in our daily bread. You know, when you talk of the x, we know that y must be 0 there. And when you talk of y, then you know that x is supposed to be 0. Then you let x to be 0. Those two are very, very important. Please don't make mistakes, because you know that that point will be exactly on the x-axis, and then this one on the y-intercept, that point will be exactly on the y-axis, which is very, very important. As you can see here, like we said, finding the y-intercept, you let x to be 0, and then finding the x-intercept here, and then let f at x be 0. That f at x, it represents the y value. I think, boys and girls, you have this one clearly. Right, and then, remember now, we are talking about the cubic function here. Then we are expecting to have a cubic equation, right? Now, how do you solve the cubic equation? When you talk of the quadratic functions, now the exponent is 2. Now we're going to have a quadratic equation. You know how to solve the quadratic equation, right? Now let us see. How do we solve the cubic equations, right? First, you need to find the factors of f at x by finding the common factor. It means, first of all, what you can do, always like we say with quadratic equation, first of all, see if you can see the common factor in that equation's name. See if you can see the common factor in that equation, and if there is a common factor, then you take the common factor out. Okay, or if there is no common factor, because you'll be having 4 terms or 3 terms, then from that one, then you can group the terms. If there are 4 terms, you can take the first 2, you group, and to see if you can take out a common factor, and then you take the last 2 as well, and then you see if there is a common factor. Then on that one also, that is another way of factorizing the cubic equations, and the other one by using a factor theorem. Of course, this is the very, very important one, using the factor theorem. You know, you'll find the value that when you substitute in that equations, then you get 0, and now you can take it from there to factorize in details. Good. And now, it means now the first thing that we talked about is the x and the y-intercept. Now you understand what is it that you need to do, especially when you find the x-intercept, right? The next point after the x-intercept will be what? Will be the turning point. The next point there will be the turning point, right? Good. Now, here is supposed to be turning points, because we agree that we are going to have a more than 1 point here, which is very important, right? Now, remember now, boys and girls, it's not the first time you hear the words the turning points. Is that correct? Which functions did we do the turning points on it as well? Yes, you are right. That is a quadratic functions, right? How do you determine the turning points of the quadratic functions? Yes, you use the axis of symmetry, which says that here you have x is equals to what? X is equals to minus b over 2a. Once you have x, now it means what you will do here, you just take this one and then you substitute it in the equations, then you have the corresponding y values, right? Now, let us see what's going to happen with the cubic functions. How do we determine the turning points? How do we determine the turning points? Of course, the first thing that you must look at is we must have f prime of x. We must have f prime of x. What is f prime of x? That is the derivative. Is that correct? That is the derivative, but especially at this point, I also refer it as a what? As a gradient. I also refer it as a gradient. And then once you have that derivative, you let the derivative to be 0. You let the derivative to be 0. I know one will say that, but why do you let the derivative to be 0? Of course, you remember that, like I said earlier on, if a is greater than 0, we are going to have the maximum turning points. Of course, you know the gradient of the straight line. Here the gradient is positive. Here the gradient is negative. But what is happening at this point here? What is happening at this point? The gradient is 0, right? The gradient is 0 there. That is why you must have the derivative, and then you let the derivative to be 0. Now, once you have let the derivative to be 0, and now you can do what? You can solve for x. Of course, you will have the values of x. X is equals to this and x is equals to that. There will be only 2 x values there. Right. Now, once you have the x values, what is it that you're going to do with those values?